Welcome to our mini lesson tonight on polynomials. It's strange, I hear my husband whispering upstairs and I'm thinking, it makes me think of when you say Polly want a cracker. Okay, that's totally besides the point. Poly means many, so we're going to have many terms. Traditionally, we think of a polynomial as having the variables have exponents going in descending order. So I might start off with a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, all the way down to a times x to the first, and let's make that a sub 1, plus a sub 0. Now these a's are just the coefficients. For example, a polynomial could be 5x to the fourth plus 3x cubed minus 2x squared plus 4x plus 1. This has coefficients in front of each x squared term, and the exponents go down in degree. We would consider this a fourth degree polynomial because of each of these monomial terms. When we look at them, we see that the highest exponent of any of them is 4, so this would be a fourth degree. I could have a polynomial that looks something like this, negative 4x cubed plus x minus 1, and this has many terms also. It's missing the x squared term, so I have gathered the coefficient is 0, and we would say the highest degree here is 3, so this would be a third degree polynomial. What we'd like to do in this video is to add, subtract, and multiply. You've seen these before. It isn't until we get to multiply that we're going to put a little bit of a twist in here. So for addition, say for example I wanted to do 5x to the fourth plus 3x cubed minus 2x plus 1 plus 6x to the fourth minus 5x squared plus 8. Well, this is really just pretty easy peasy, because if we can imagine that there is a 1 in front of each of these parentheses, and when I distribute a 1, everything stays the same. So this will become 5x to the fourth plus 3x cubed minus 2x plus 1 plus 6x to the fourth minus 5x squared plus 8. Combining like terms, I have a 5x to the fourth and a 6x to the fourth gives me an 11x to the fourth. I don't see any other x cubed terms, so it'll be plus 3x cubed. I don't see any other x terms, so it'll be minus 2x. But I do see the 1 and 8 combine and give me 9. Another example can be seen when we subtract. So when we subtract one polynomial from another, I can take 4x cubed minus 3x squared plus 6x minus 1 minus negative 6x cubed minus 2x squared plus 5. Oh, my 5 went off the paper. Okay. Now, in this case, if we think of having a 1 in front, we're distributing a negative 1, which means that every term in the second polynomial will have its sign flipped. So after I distribute, this will become 4x cubed minus 3x squared plus 6x minus 1. Minus times minus is plus 6x cubed plus 2x squared, but a negative times a positive 5 will be negative 5. Combining like terms, 4x cubed and 6x cubed is 10x cubed, negative 3x squared plus positive 2x squared is negative x squared. There is no other x term, so the linear term is 6x. Negative 1 and negative 5 is negative 6. We'll have you stop for a moment and do one or two of these, and then we'll join you in a moment. Okay, we are now ready to multiply. Now, in terms of multiplying, you've done a lot of multiplying before. For example, if you did x plus 3 times x minus 4. I used to like to think of it as everything times everything. You distributed the x, you distributed the 3, and your teachers used to abbreviate this as FOIL. There's really nothing wrong with FOIL. However, because we're aiming to divide polynomials tomorrow, which could get a little ugly, I'm going to switch us over to what I call the box method or the tabular method. So I'm going to make a grid, and I'm going to have x plus 3 times x minus 4. And what I'm going to do is fill in the grid as I multiply. So for example, x times x will go in this box, will be x squared. 3 times x will go here, 3x. X times negative 4 will be negative 4x. And then we're going to have 3 times negative 4 is negative 12. If you look at the box, you see there's only 1x squared, but negative 4x and 3x combine to give you negative x, and we're left with a negative 12. Let's do another box example. So I'm going to add a page here, and let's do x cubed plus 3x squared plus 5 times x minus 4. Now what I want you to notice is when I set up the grid, I'm going to have my x cubed, I'm going to have my 3x squared. Since the x was missing, it means it was 0x plus 5. So it's going to be x cubed plus 3x squared plus 0x plus 5. And over here I'm going to have 1x minus 4. Now I'm going to start off doing the x here times each of the terms on the top of my table. So x times x cubed is x to the 4th. X times 3x squared is 3x cubed. X times 0x is 0x squared. X times 5 is 5x. Now I'm going to go ahead and multiply each term in the top of the table by negative 4. Negative 4 times x cubed is negative 4x cubed. Negative 4 times 3x squared is negative 12x squared. Negative 4 times 0x is 0x. Negative 4 times 5 is negative 20. What you're going to notice is all the like terms in the table are along the same diagonal. So x to the 4th, there is no other 4th term, but the like terms here are on this diagonal, and that's going to give us negative x cubed. The x squared likes terms are on this diagonal, so negative 12x squared plus 0x squared is negative 12x squared. If we look at the next diagonal, 0x and 5x is 5x, and we're left with a minus 20. So if I had FOILed that whole thing out, this is what I would get. Now I'm going to put in 1 or 2 more problems for you to do, and I really want you to use the tabular method so that tomorrow when we do the division, this will not be difficult to you. Okay, good luck, and try the next couple of problems.